Hello everyone, today we will start transformation of matrices or elementary row and column operations. There are 6 operations, 3 for row operation and 3 for column operation. So there are 3 elementary row operations and 3 elementary column operations. So let us start first operation. So these are 2 operations. One is for row operation and other is for column operation. So here we can interchange any 2 rows or we can interchange any 2 columns. Symbolically it is written as Ri is interchange with Rj, means we can interchange Ri with Rj. I and J stands for the ith row and jth row. Similarly, we can write the column interchange is Ci with Cj. So I is for column, ith column and J is for jth column. So here we can interchange any 2 row or any 2 columns. For example, transform this matrix into unit matrix. So unit matrix means 1 0 0 0 1 0 0 0 1. Applying the row operations, elementary row operations, we get here interchange row 1 with row 2. Interchange row 1 with row 2. So here we get 1 0 0 0 0 1 0 1 0. Now interchange row 2 with row 3. Here we get 1 0 0 0 1 0 0 0 1. Similarly, we can apply here elementary column operations. So now applying the column operations, we get 0. This is the given matrix 0 0 1 1 0 0 0 1 0. We can interchange any 2 columns. So first interchange. See this matrix and here we can interchange column 1 to column 3. So interchange column 1 with column 3. So now we get 1 0 0 0 0 1 0 1 0. Now interchange column 2 column 3. Column 2 with column 3. So here we get 1 0 0 0 1 0 0 0 1. Now we get our required matrix, that is unit matrix. Let us start next operations. Operation 2. Operation 2 includes 2 operations, that is one is for elementary row operation and other is for elementary column operation. Similarly for operation 3. So operation 2 is multiplying the elements of a column or a row by a non-zero scalar. Symbolically it is written as K is multiplied with Ri and it is written as Ri is changed into K into Ri, where K is a non-zero scalar. Similarly for column operations, we can multiply K with any column. Next, operation 3. Replacing a row or column by adding to it multiples of corresponding elements of another row or column by a given non-zero scalar. Symbolically it is written as Ri is changing into Ri plus K Rj. That means K is multiplied with any row and we can change one row with same row plus K into Rj, other row. Rj means other row from Ri. Similarly for the column operations, Ci changing into Ci plus Kcj. Let us solve one question. Transform this matrix with unit matrix. So This is 6, 3, 2, 2. This is a order of square matrix, order of 2. So we transform this matrix with unit matrix. So applying operation 2 and operation 3, we can change into unit matrix. So multiplying 1 by 3 into row 1 with row 1 and multiplying 1 by 2 by row 2. So we can write this row 1 is multiplied with 1 by 3 and row 2 is multiplied with 1 by 2. So this matrix becomes 1, this is 2, 1, 1, 1. And next, applying operation 3. Row 1 is changing into row 1 minus row 2. So here we get 2, row 1 is minus row 2. Row 1 is this, row 1 minus 2. So 2 minus 1, that is 1. 1 minus 1 is 0. So row 2 is 1, 1. So now applying this operation, changing into row 2 with row 2 minus row 1. Here we get 1, 0. Same row 1 and we can apply the operation in row 2. That is row 2 minus row 1. So 1 minus 1 is 0. 1 minus 0 is 1. So here we get our required unit matrix. Let us start inverse of a matrix. We can define inverse of a square matrix. If a matrix is not a square matrix, then we cannot define the inverse of the matrix. If A, B are two square matrices of same order such that AB is equal to BA is equal to I is the unit matrix of same order as A or B. Then A is called inverse of B and B is also called inverse of A. Symbolically, A inverse is written as A inverse and B inverse is written as B inverse. A matrix whose inverse exists is called invertible matrix. Invertible matrix. For example, 2, 1, 5, 3 into taking two matrices of order 2, 2, 1, 5, 3, 3 minus 1 minus 5, 2. Multiply these two matrices, we get the unit matrix of order 2, that is 1, 0, 0, 1. So this matrix is inverse of this, and if we multiply this matrix with this matrix, if we get the unit matrix, then it's called this matrix is called inverse of this matrix. So here these two matrices are invertible matrices because the inverse of these two matrices exist. Let's start uniqueness of inverse. If inverse of a matrix exists, then it is unique. And next, inverse of product. If A and B are invertible matrices, that means inverse of A and B are exist. If inverse of A and B exist, then AB whole inverse is equal to B inverse into A inverse. Let us start inverse of a matrix by using elementary operation. We can use row operations and column operations. If we will find the inverse of the matrix A and we will use the elementary row operations. So first of all, we will write A matrix is equal to I into A. applying the elementary row operations till we get I is equal to BA. So B will be the inverse of the matrix A. Similarly, for applying the column operations, when we will apply the elementary column operation, we'll write A is equal to A into I. Applying the elementary column operation till we get I is equal to AB. So here B will be the inverse of the matrix A. So when we will take the square matrix of order 2, that is A1, B1, A2, B2. So first of all we will write this matrix A is equal to IA. Here we can apply the elementary row operations. When we will apply the elementary row operation, first we convert this matrix into unit matrix of order 2, that is because this is a matrix of order 2. So first convert by using the elementary operation. First convert this element is 1. First convert this element is 1. Next convert this element is 0. First convert this element is 1. Next convert this element 0. Applying the row operation. Next convert this element is 1 and next convert this element is 0. Then we get our required unit matrix. This is for row operation. When we will use the elementary column operation, then we will take the rule. First convert this element is 1. Next convert this element is 0. Next convert this element is 1. Applying the elementary operation. At last convert this element is 0. Similarly, for order 3 matrices, when we will take the order 3 matrices, first using the row operation, first convert this element 1. After that, these two elements are 0, 0. Next convert this element 1. Then we will use this element 0, next this element 1 and this two element 0 in same step, and next step we will get here the value 0. This is for row operation. When we will apply the elementary column operation for order 3 matrix for finding A inverse, then we will convert first this matrix, this element is 1. Next convert this two element is 0. Next convert this second row or second column element, that is A2 element is 1. Next convert this element 0. Next this element 1 and convert this two element 0, and then we get here also 0. And applying this technique we will get the inverse of a given matrix of order 2 and order 3, applying both either elementary row operation or elementary column operation. Let us take one example. So this is a matrix of order 2. We will find the inverse of this matrix. So first of all, we will write this format: A is equal to IA, because here we will use the elementary row operation. So first of all, we will write this matrix is equal to I, unit matrix of order 2, that is 1 0 0 1 into 1 2 2 minus 1. So follow this rule, that is first convert this element 1, this place element 1, and next this element 0, next this element 1, and next this element 0. So here see, first element is 1. Next, convert this element to 0. Now here we will apply 0, means R2 is changing with R1 minus R2 minus 2R1. So here we get 1, 0. R2 is 2 minus 2R1 means 0. Here row 1 is 1, 2, that is 0. This is minus 1 minus 2 into 2, that is 4, minus 5. So here we get 1, 0, next 0. 0 minus 2R1 minus 2. 1 minus, that is 1. So here this matrix is A. So now that implies we get here, next convert this element is 1. So we multiply here 1 by minus 1 by 5. So row 2 changing with minus 1 by 5 into row 2. So now we get here 1, 2, 0, 1. So now here we get 1, 0. This is minus 2 into minus 1 by 5. This is 2 by 5. This is minus 1 by 5 and this is A. Now convert this element 0. So here this is the row 1 element. So we will change here the row 1. So R1 is changing with R1 minus 2 R2. So that implies we get here 1, 0, 0, 1. Here we get the unit matrix of order 2. Now here first row 1 is changing it. Row 1 minus 2, row 2. So 1 minus 2, row 2. 1 minus 2 into 2, 4 by 5. So this is 0 minus 0 minus minus plus 2 by 5. This is 2 by 5 minus 1 by 5. So here we get 5 minus 4. 1 by 5, 2 by 5 into A, 1 by 5, 2 by 5, 2 by 5 minus 1 by 5 into A. So here we get the unit matrix I, and this is the inverse of the matrix, that is A inverse and A. So here we get I is equal to VA and B is the inverse of A. So here 1 by 5, 2 by 5, 2 by 5 minus 1 by 5 is the inverse of the given matrix. Similarly, you can use the elementary column operation for this matrix, and you can use the elementary row operation or elementary column operation for finding the inverse of order 3 matrix.